many different planets in our solar system have their own moons. For example, the moon is Earth's moon, but Titan, one of Saturn's moon, is very, very weird and interesting in very different ways. And there are new studies that are being conducted in order to find out more about Titan and what its surface could tell us about how that moon is so different from the rest of the moons in the solar system, and maybe even the key to life. And there's so much science going on around on it, and that's why scientists like Dr. Lauren Schurmeier at the University of Hawaii, she studies Titan and studies the crust and surface and craters on Titan. And in this episode, I'm going to be speaking with her to learn more about this really, really weird moon and all the interesting things that are going on its surface, or maybe even under its surface. Let's get right into the episode. Let's go. Hello.
Hello.
Thank you so much for joining me today.
Of course, I'm very excited.
So before we get started and before we blast off into space, can you please introduce yourself to the listeners?
Yes, I am Lauren Schurmeier. I am a researcher at the University of Hawaii at Manoa, and I have a PhD in Earth Environmental Science, but the focus of my research has always been geophysics and planetary science.
That's awesome. So, how did you get interested in science?
Yeah, so I have just loved science since I can remember. I don't know. Um, my grandpa actually worked for NASA.
Oh, wow.
Yeah, that was before I was alive. So I didn't really see that happening, but I did grow up visiting him, and he had like pictures of Jupiter and rocket launches on his walls. And he had these like planetary magazines that I would steal and I would read them. And so I just consumed all of the science that I could. And you know, I just looked for other scientific opportunities. Like in high school, I did science fair as much as I could because I just loved doing, experiments and stuff like that. And I loved competing in science. So I did Science Bowl. I don't know if you've heard of that, but it's like a buzzing competition for high school students in science. So I love doing that. And I went to science summer camps, stuff like that. Like I went to the Cosmos program. I'm sure there's different kinds of similar programs at different universities, but some of them
Mhm.
you can go and take classes and learn from that. And so when I did that and I got to meet professors and scientists and use their telescope, I just became
Wow.
obsessed. And I was like, yes, I gotta go to college for this.
Yep. And that's how you ended up studying space as a living now, which is really, really cool. And we'll get more into those studies later in the episode.
Great.
All right, so this entire episode's all about Titan, one of Saturn's moons. So can you please describe to us what Titan looks like, or just some notable features and notable facts about this really, really amazing moon?
Oh yeah, I can describe Titan. So Titan is a weird moon. So it's a moon of Saturn. So think really cold because Saturn is far from the sun, right?
Yep.
And it's bigger than our moon. So picture a big moon. And then it has a huge atmosphere, which is just totally weird for a moon. There's no other moon with an atmosphere. And the atmosphere actually makes everything different about Titan. So it has an atmosphere sort of similar like the Earth. So it's mostly nitrogen, but it has a little bit of methane. And then reactions that happen in the upper atmosphere um, cause the nitrogen and a little bit of methane that's present to break apart, recombine, and make all kinds of organic molecules. And so this actually makes haze layers. So the atmosphere is orange because of this, and
Wow.
it's really hard to see into it. The atmosphere has these solid organic molecules that form that fall to the ground, and they form these sand dunes, these long linear sand dunes,
Wow.
because there's wind on Titan, because there's an atmosphere. Um, it also has climate and weather and rain. It's so cold there that it rains liquid methane. That's how
What?
cold it is there.
Wow.
Yeah, it's kind of like like butane that's in like a lighter.
Oh yeah.
Uh, it's like that. So
It just falls out of the
methane,
sky.
yeah. So methane, when it's, the right temperature and pressure, will turn into a liquid and it'll just rain, just like on Earth. So we've seen clouds, we've observed rain, we saw the surface get like wet, but I say wet like that because it's methane and it's not
Yeah,
water.
it's not
But
water.
but the ground is made out of water because it's an icy moon orbiting Saturn, and that's what the moons are made out of there. So yeah, it has sand dunes, it has lakes and seas. We have rivers. The rain forms these like channels that we assume are made out of methane. What else? There's mountains, and then there's very few impact craters, which is what I was really interested in because if you picture any other moon of Saturn, it's just a bunch of craters.
Yep.
But if you picture Titan and you see all the pictures of it, there are almost no craters. It's weird. You can count them. There's only 90 maybe
Wow.
craters. And honestly, there's only like 15 that look like pretty good craters.
Pretty good craters. They
And
got to
then they're
pass.
all
They got to
really
pass.
shallow. Yeah, yeah.
Wow. And we'll get more into your studies later. But how are you studying Titan's crust and what are some of your findings?
Yeah. So the reason I'm studying the crust is because I think we can learn things about the interior, um, and potentially the atmosphere. I
Mhm.
actually think the crust might be why Titan has an atmosphere
Wow.
because we think that, well, some people think that the ice shell might have methane trapped within it. So it's frozen solid ice, just like all the other moons, but for whatever reason, Titan has more methane. And when it crystallized, it trapped methane within the solid ice. And the methane is forming this like kind of crust inside the ice. So it's called a methane clathrate. It's a form of ice with methane in it. So it's just ice with gas in it rattling around. And the crust, if disrupted, could potentially release that methane, which could maybe explain where the methane in the atmosphere came from, which is pretty
Wow.
cool.
That's really
Yeah.
cool.
Yeah. And so I study it through modeling. Do you want me to get into that?
Yeah, sure.
Um, yeah, so I didn't think of this idea, but other people have thought, well, maybe the upper layer of the ice shell is made out of a methane clathrate. So it's that ice with methane in it. And what's interesting about that is that that changes the thermal properties of the ice. And
Hmm.
so, because of that, it actually retains heat really well. And so, it acts like a blanket. And so, if the crust of Titan was made out of this clathrate, then it acts like a blanket and it warms the interior. And that can cause convection, which is really interesting because people used to think, well, maybe the inside is cold and slow and not moving. But now we think, hey, maybe now it's warm because it has this blanket on it. And that might be, affecting things on the surface, like impact craters. And so that's why I model impact craters to see, can the impact crater shapes that we see tell us something about the thickness of this crust? And that crust is just important for the evolution of Titan and, how it moves things around, stuff like that. And so we saw that the craters on Titan are much shallower than we would expect compared to, I don't know, any big moons of Jupiter or any of the other moons of Saturn. We like have done the math, we see them, they have deep craters. We thought, hey, why does Titan not have deep craters? And so what we think it is that if there's a clathrate crust, it's making things warm. And if you ever picture warm ice,
Yep.
it'll start to flow, right?
Hmm.
So I teamed up with some scientists at MIT, led by Shidru Wakita. And so what they did is they tried modeling an impact into a methane clathrate crust, like
Oh.
planet,
Hmm.
and they found that the craters are shallow,
Wow.
but not as shallow as we observed. And so what I did is I studied the like long-term evolution of them. And so I did a computer model where I put in all of the thermal and mechanicals, all the physical properties that we know of the clathrate and the ice and the ocean below. And I make a crater shape based on their impact modeling. And then I evolve it through time and I see what happens. And what happens is these craters start to kind of flow and flatten. And so what I found is that for certain thicknesses of that crust, you actually can reproduce the really shallow crater depths that we see on Titan. And so this is like a new line of evidence for not only the fact that there's probably methane clathrate crust on Titan and not just ice, because otherwise the craters would be really deep. But we also figured out how thick it might be. And I think just based on the simulations that match the observed craters, we think the crust is about 5 to 10 kilometers thick. And so that's about maybe 6 miles thick, which sounds kind of big, but for a planet, that's kind of thin.
Yeah, for a planet. But for Titan, since it's a little bigger than our moon, that would be a lot,
Mhm.
right?
Yeah, and it's a lot of methane too. And so
Yeah.
that's like a great source of methane to maybe go into the atmosphere, which is maybe why Titan's so weird.
Yeah, because it has the water cycle, but not water. It's methane. Because
Yeah.
it goes up, it comes down, it rains down. And now you're saying it's trapped in the ice. That could be like groundwater on Earth, how it's trapped in the ground. So that's really interesting. It's really weird and really cool.
Yeah, it's a lot like Earth, but also different. Yeah.
Yeah. And it's also special because it has this self-healing property, as I could call it, but
Yeah.
it's it's just the craters, they flow, which is interesting.
Yeah.
Because
Well,
usually when you think of craters, you think of all that moon dust and like all the rocks scattered, big explosions and everything. But Titan just proved us wrong.
yeah, and it's cool because we thought, out at Saturn, everything's just gonna be so rigid and cold, but
Yeah.
here it is,
The
moving
exception.
around.
Yep. Could this have
Yeah.
something to do with the quest for life in our solar system or outside our solar system?
Yeah. So I think it's important because if Titan was cold and the ice shell was not moving and not convecting, that's probably not a good sign for life because on Titan, there could be Earth-like life and then there could be really weird life. And so
Mhm.
there's liquid methane lakes and rain, and maybe life could build itself out of that. I don't know. I
Mhm.
hope so. I don't know.
Titan
But
aliens.
Titan aliens, but like all the life we've seen on Earth needs water. And
Yeah.
so if we go off of that and we know that life needs energy and life needs water, then Titan has both of those things. It has water in the ocean under the ice shell, and it could have water anytime there's an impact crater that melts the ice shell and creates a little pocket. And Titan has food, so like energy. It has those organic molecules in the haze that are falling to the ground. That's a snack for life, and that's what life can build itself out of. And so, if life is in the ocean, you kind of want all that atmosphere molecules to get into the ocean. And the only way they can do that is if there's some way to bring things through the ice shell down to the ocean where it can, get snacked on. And so if Titan has a convecting crust, then that's one way that you could maybe bring those molecules down to the ocean and make Titan a better place for life.
Yeah, you kind of gotta mix the batter, right? You gotta
Yeah.
bring all the food and all the nutrients down into where life could actually thrive, and that would eventually, or maybe Titan even has life on it. We just don't know it.
Yeah. And how would we know unless convection could bring those molecules back up to where we
Yeah,
can detect them?
yeah.
Yeah.
That's so interesting. And that brings me to future research. So what future research are you and your team planning to do, and why will it be important to finding out more about Titan?
Yeah. So I want to look more into how this weird form of ice, how these clathrates could be affecting Titan as a globe. And so if you look at Titan, you'll notice that its shape isn't round. It's actually really squished.
Wow.
Most planets that are really big are a little bit squished, like Jupiter, Earth, all the, big planets and big moons, because they're spinning and they have gravity, they'll squish a little bit. But Titan has squished so much more than it should have based on how fast it's spinning. And so, what I think, and I'm not the first person to think of this, is that maybe that methane clathrate crust that's on the outside could be heterogeneous. So, maybe there's some in certain places, or it could be heterogeneous in that it could be a methane clathrate, or remember, there's liquid ethane on Titan too.
Ooh,
That could be forming a clathrate. And if that forms, then that could make the crust even denser. And so what I'm trying to see is, well, what if you had denser ethane clathrate only at the pole, kind of pushing it down because it's heavier than methane, because remember, it's two
mhm.
carbons instead of one. So it's a heavier molecule. Um, what if you only had the ethane up at the poles, which is where we see all the lakes and where we think
Oh,
ethane rain might be happening? So if ethane rain's happening at the pole, it's sinking into the crust, it's kicking out that methane from the clathrate, making it heavier, and then pushing down on Titan only at the poles, then it would make the whole shape of Titan squished.
wow.
And so this would explain how the methane's getting back into the atmosphere and then the shape of Titan. And the reason I want to look into this is because people have hypothesized that this was a thing, but we haven't actually done the physical models to see how the entire planet bends and whether it's able to bend and how slow it bends. And so I just got some NASA funding to look into how the whole planet will deform with
Wow.
different kinds of clathrates. And so that'll teach us something about, the thickness of that clathrate layer and maybe how old it is and have implications about the interior of Titan.
Wow, that's so cool. We gotta do another episode when you get those results because
All
that
right,
sounds
yeah.
sounds sounds really cool because all of that physics and all that chemistry that's involved in it, and plus you have to 3D model that like on a computer and bringing all those three things together is they're kind of out of this world because you wouldn't think that you could do all these things on a computer. All I know I can do on my computer is like edit videos and be on a Zoom call with you right now. But but you can do so much on it and like all of these simulations that you're talking about, these are all run on the computer and using all of this real life data and then putting it into the computer and then finding out these desired results. It's just so cool to see all of these fields merging.
Yeah, and it's great because I don't have to go anywhere. The spacecraft goes and collects some data, and then I run my models based on the physics we know works on Earth, and I see, what makes things look like what we observe on the NASA missions and which things don't. And so it kind of teaches you what it is, and I, don't even have to go anywhere. It's great.
Well, there's one downside. You can't have a free vacation to Titan though. That's the only downside.
I know. It'd be cold though. Really
It'd
cold.
be really, really cold. So, speaking of the future, again, what advice do you have for the future scientists and kids who are interested in science?
Yeah, what a cool question. Yeah, I would say, try to find other groups of people who like science. I did that. I did science fair, science bowl. I'm sure there's all kinds of other competitions or clubs you can do. This podcast is like a perfect way to do that, is to, create a little science community that you can work together in. I think that's a good way to teach each other and, stay inspired and get through the hard spots. And the other thing is just, don't feel like you have to be perfect. Like some things will be hard, school will be challenging sometimes. I had a hard time with math, and that's okay. I found people to study with, and I learned that we could struggle together and ask for help, and you'll get through it. Like things will could be hard, but you just gotta keep working hard and get through it and just make sure that you love what you're doing.
That's some really, really great advice. Thank you so much again for joining me today. I really enjoyed it. I learned so much. And hopefully we'll do another episode when we figure out why Titan is actually that squished.
Yeah, sounds great.
And will you take me on a trip to Titan?
I hope so. Let's try.
Yes. I have to get a really, really comfy spacesuit for that.
Yeah, totally.
Thank you so much. Thank you so much for listening to this episode of Spectacular Science. Spectacular Science, produced and hosted by me, Akshay Raman. Our theme song and additional music are by Charan Ramachandran. Special thanks to Dr. Schurmeier for accepting my interview invite. I learned so much about Titan, and there's so much amazing research that you're doing, and it's just so interesting. And thank you so much for coming on the show. Please visit my podcast website, spectacularsci.com, to find interactive activities, articles, and blog posts. That's spectacularsci.com. Do you have a science question you answer on a Spectacular Science episode and get a special shout out? Grab an adult, head over to spectacularsci.com/contact. There you can find a contact form and you can send me your amazing science questions. You can also tag me on Instagram at SpectacularSciPod. That's at SpectacularSciPod and ask your questions there. Thank you so much. Also, don't forget to subscribe to this podcast wherever you're listening right now. It really encourages me and you'll be updated on the new episodes. So subscribe and share this podcast with your friends and family. Thank you so much. Thanks for listening, and we'll see you on the next episode of Spectacular Science next week. Keep thinking about science.